This.
A huge one, actually. I've been around a few places for work conferences and stuff.
This one is on.
In the coast of it. Arizona is very trash. A little bit. To be honest.
Right over there, yeah, toward the door.
Right. One of the things I'll tell over the
Right.
I'll never be able to see America before.
Welcome to MadJS. I'm Josh Thomas. As you can tell, I'm not Eric. I'm about 2 feet shorter than Eric. He was unable to make it here this month, so I'm filling in for him, considering he drives all the way from Chicago just to be here for this event once a month, so we'll let it slide once in a while. The pizza and drinks tonight are sponsored by Flexion, so thank you. So, is there any JavaScript-related news that happened in the last month that we want to talk about? I've got Node version 4 came out. I was pretty excited about that. Right, the completion of iOS or IO.js and Node coming together for bringing the fork back in. Any other news? No? All right. Does anyone have any openings they want to talk about? Positions available? All right. That's first. So Scott's here to talk about ToneJS and music for the web.
Well,
It's short.
yeah, that was
Yeah, sorry. Maybe I should have waited for people to finish their pizza.
Should have well, it's better for Scott to finish his.
Yeah. Finish?
I'll eat after. Not a big deal. All right. Let's see if we can get, hopefully we can get the audio working again. Fancy. Oh, there we go. Nice, nice, nice. All right, we'll see if that works. All right, so let's see here. I am a professional, I promise. So my name is Scott Fradkin. I do work for the sponsor of tonight's event, Flexion. We actually do have some people we're looking for. We're looking for Java developers. We're looking for Angular developers and .NET developers. So if you know anyone who fits the bill, come talk to me. We can exchange info and talk further. So I got involved. I got involved in this because I've known Eric for many, many years, and he's been trying to get me to come to MadJS for like forever. And I'm always like, man, I got other things to do. But we both share an interest in music and creating music and generating music. And so I said, hey, have you ever thought about doing a presentation on music in JavaScript? And I said, I've been kind of looking at this thing called tone.js. Any interest? And he said, sure. So it figures that, this would be a presentation he'd be very interested in, and he's not even here. So I don't know. And hopefully this all gets edited out. Okay, so this is kind of an intro to music synthesis with ToneJS, and it really is just an intro. It doesn't go super in depth, because if anyone's used the web audio API at all, it's an incredibly complex thing, and that's where Tone comes in. It hopefully makes things easier. So I'm Scott. We've gone through that. I'm really a long-time Java developer, heavy on the server side, Java. But over the past year or so, I've gotten more into JavaScript, and I actually mostly do JavaScript at this point. So, going from a JavaScript, not really liking that, to a JavaScript liker, this is a good thing. But I've always been into music. I've always liked listening to music, but I'm not a musician. I don't really know music theory, but you don't really have to know any of that to get into music. It's an enjoyable thing. So I was involved in like the tracker scene ages and ages ago, and I don't know how many people know anything about the tracker scene. And hopefully the things that I did create way back then are completely lost in the annals of time. I'm sure somebody can probably dig something up, though.
What is the tracker scene?
Yeah, exactly. It was an offshoot of the whole demo scene. It's the music behind crazy graphical demos that people would put together for competitions. So a tracker is essentially the precursor to today's DAWs. So that's where those came from. Last year I learned about this cool thing called live coding. It's creating music in a live REPL. So you're modifying code and hearing change in music all at once. And it's a fantastically fun thing to do. And you don't have to be a musician to really get into it. Like I said, I'm not a musician, but it's a lot of fun. But what it did do is it piqued an interest in me to really try to get more people interested in programming through music, especially kids. The whole, hey, create a game kind of thing can only go so far with some people. It's just not. There's a lot to it. It might not be as interesting to everyone. But music is kind of like a real instant thing. One line of code can play a note of music. So it helps generate some interest. And so in my searches on the internet to try to find more and different ways to generate music, I ran across ToneJS. And so that's why I'm talking about it tonight. So we could talk a little bit about the dark days of browser-based music. And I found this awesome Internet Explorer 4.0 icon here. Hopefully Microsoft doesn't sue me. I know. I'm sorry. It's the wonders of Google. I'm sorry. Blame Google. So I introduced this awesome thing called the BG Sound element, and it's forevermore associated with GeoCities and playing background MIDI music. And that's all we're going to say about that. BG Sound was proprietary to IE4. I don't think anyone else ever supported it, and it's a basic attempt to get music into the browser, but you had to have a sound file behind it. So we go on a little bit to the future, and now we get the embed elements, and we can embed audio and video files. That works okay. Now with HTML5, we get audio, and I believe there's also video. But it's still kind of limited in what it can do. It's still file-based. Here's a file, play it, here's some controls. You can go backward and forward and loop things. But it's not so helpful if what you want to actually do is generate the sound on the fly or using a synthesis method. So here comes Web Audio API. It's a low-level API. And you can generate and control sound through JavaScript APIs. And you can look at the Web Audio spec. It's quite long, and there's a lot of stuff to it. So what can you do with it? How many people are familiar with Web Audio? I know Bryce is. A few people, all right. So you can play audio files, standard fare there. You can generate synthesized audio. That's the fun part. You can analyze audio data. So there's a whole API that lets you read the actual data that's going through. And you can manipulate that audio. So you can change it on the fly. That's great. It gives you a lot of control, but it's really, really low level. It's almost like a C interface in some ways to the audio subsystem.
What you're doing.
Yes.
With like bits of audio data.
Yes.
It's really crazy.
It is. It is crazy. So what about ToneJS? Where does ToneJS fit in? So where it fits in is it's an API that sits on top of Web Audio. And it abstracts those Web Audio interfaces to make it a lot easier to use. And the way it does this is is it creates components that are basically building blocks that are, the analogy is to an analog synthesizer. So analog synthesizers come with a bunch of different modules. You have oscillators, which create tones and sounds. You have envelopes that shape that sound. You have filters and various effects. And you plug them together, and then you have it output. And ToneJS is actually pretty similar in that regard. It has a bunch of different building blocks that you basically wire together and send the audio to the output. And it uses the underlying web audio APIs, but it abstracts out a whole bunch of stuff for you so that you don't have to worry about it. So that's kind of what I said there. So tone.js, these are kind of like the big areas of tone.js. There's this object called transport, an object called master. Transport deals with timing of audio. Master represents the output of the audio. There's a lot of different representations of time, which we'll get into. There are sources, which generate sound. There are signals, which signal change in different attributes of the sound. Components are again those little building blocks that we talked about. And all these things kind of bundled together create effects in instruments. And we'll kind of see some of that here. So the first most important thing with tone is transport. So what transport does is gives you precise timing. And it does that by creating an oscillator down in the bowels of web audio to use for that timing. So the oscillator is running and it oscillates at a specific frequency, and it hooks back into it with callbacks so that tone knows how much time has passed during each oscillation. You can use it to schedule events. So you can schedule periodic events. If you have something that needs to happen every, 1 millisecond, every second, you can schedule those and create a callback function that it'll call. You can schedule future events. So perhaps you are playing a game, or you're creating a game, and you have an avatar that's walking down a hallway, and you want to trigger something to happen after like 3 seconds of walking. You could do that as well. Tone.transport is responsible for the overall tempo, and so you can change the tempo on the fly, and it will actually scale everything that's running based on that tempo change, with no other changes to any of your coding. So tone.master, really not much to talk about here, but it does represent the output, and it controls the overall volume. So time is pretty important when it comes to audio, especially when you're talking about music and periodic audio. And you can express time in many different ways in tone. So you can express time in seconds. So in here we have 1.5 seconds or 15 seconds. You can also use a time signature relative notation, and this is a fantastic way to relate to time, because time, when you think about it in a musical sense, is broken up into notes and measures, and based on your tempo, things like a quarter note or a half note actually take a longer or a shorter time period, depending on how fast the tempo is going. So you can express the length of a note as 4n, for example, which means a quarter note. And it will always play for the precise time of a quarter note, whether or not your tempo is 180 beats per minute or your tempo is 60 beats per minute. If you want to, you can use transport time in bars, quarters, and sixteenths. They throw that in there. You can express time in a frequency. And you can always express a time that's now relative. So plus 1.5 means now plus 1.5 seconds. And you can use any combination here as well with time signature notation. And you can create expressions that combine everything together. And tone will freely convert between all the different types of time notation that you use. So you can use whichever way you want to express time in, and it'll convert everything behind the scenes. So how do we actually create sound and tone? You can use a microphone. Now, I have to say I tried using the microphone input. I could not get it to work. And I don't know if that's just set up with my laptop or if it just wasn't working through Chrome. You know, Chrome's constantly updated and things break. So that really doesn't surprise me. Or maybe my settings were blocking it. You can have a player source to play files. So just like anything else, you can just use a file, an MP3, a WAV, or whatever, as the input source. You can use an oscillator. Oscillators can have a sine wave, a saw wave, square, a triangle. Those are all the different kind of basic oscillator waves that you'll find in any analog synth. There is a pulse width oscillator plus a pulse width modulation oscillator. Now, the easiest thing to use if you're actually synthesizing your audio, though, is called the omni oscillator, because it encompasses all the other oscillators into a single oscillator. So you can use that for any of the different types. And there's also noise. All your favorite noise generation, white, pink, and brown. It's a real thing. It's a real thing.
According to my dad, it's all noise.
It's all noise. But noise oscillators are typically used for drum sounds. So I've got some demos interspersed in here, and hopefully the sound will work, and if not, we'll figure it out. So the first thing is pretty simple. I'm gonna create an oscillator with a saw wave, and I have a little text box so that we can actually change the note value to modify the frequency of the oscillator. So we'll cross our fingers here. Oh, I can't change. That's loud. It won't let me change the volume. Is there a volume thing somewhere? My apologies for not testing how loud this would be.
Then a volume control first.
What can you do?
We're gonna try it now.
All right. Awesome. All right, so this is just a plain old saw oscillator. And I tossed over to the side here. That's all I'm using to create the sound. I'm just creating an oscillator, giving it a note and a wave type. So we can change this. Can use a C2. And all I'm doing is changing the frequency value on the oscillator. So, pretty simple. I should have done some brown noise. Darn. So there's a couple more lines of code in there, but essentially that's the meat of the code. You create an oscillator, give it a note, and connect it to master, and off you go. And you can change those values real time. All right. Let's put this back up here. We have signals. Many attributes of the components are actually signals, and if you've worked with web audio, it mirrors what web audio does here as far as how web audio uses things under the covers. So values like the oscillator frequency, it's a signal with a behavior. So it's an actual object, and this allows you to set up future changes to that signal, such as ramping frequency. So you can tell it to change the frequency of an oscillator over a certain period of time, or moderate it up and down with an LFO if you want to. Components. So components are building blocks for modifying sources. Things such as LFOs, so low frequency oscillators. These are oscillators that are like 1 hertz to 10 hertz, so kind of slowish oscillators. But you use those to modulate cutoff frequency values to get different sound effects with your audio. Envelopes. There's actually a fantastic demo that the creator of ToneJS created that actually shows you how envelopes work. And envelopes change the amplitude of an oscillator or the frequency of an oscillator, but it changes it over time, and you can modify the different values involved. Different filters are components, and also gates, and there's a whole list of them. So, second demo, same oscillator with the saw wave. We're going to add an amplitude envelope to it. So the interesting thing with the amplitude envelope is instead of having a constant sound, what that does is it allows us to trigger the sound. So this is how a synthesizer works with a keyboard. You press a key, it actually triggers an envelope to kick off an oscillator to produce a sound over a specific period of time. So that's kind of what we'll show here. Oh yeah, right. Okay, so here's the setup. I'm like, wait a minute, what did I do? No, it works. So the setup here is we create an oscillator. We add an amplitude envelope. I just have some default values in there. So you're connecting the oscillator to the envelope, and the envelope connects to the master output. And then when we hit play with envelope, see now it's not working. Now I'm sad. Well, all right, we'll try this again. Something didn't get cleaned up. Oh. Well, my apologies. Not everything works the way I want it to all the time. What should have happened is you should have heard the note for a second. I must have modified something somewhere, and now it's not quite working. But that's what the envelope does for you, and it's essentially there's a release value that you specify on the envelope. That's essentially how long the note will play for. So it should have played for a second. We'll move on though.
What's the sustain?
Sustain. So with tone, the sustain is a value from 0 to 1 that is the amplitude, the sustain amplitude. So it's not actually the length of time for the sustain, but the amplitude of the sustain. So your decay value is the time it takes to go from maximum amplitude down to the sustain amplitude. So you can all Google ADSR envelopes, and that's what the envelopes are. Tone comes with a whole bunch of effects by default, and effects are just things that change the sound. So we have delays, chorus, bit crusher. There's a number of different built-in effects. And if you look at how they're implemented, they generally consist of a bunch of different components plus signals to modify things over time. So, gosh, I hope this works too, and if it doesn't, I'll be really sad. You know, you can check things and check things and check things, and then they still don't work. So, this is, again, our oscillator with the saw wave. This time we're going to connect it to a low-pass filter and use an LFO, a low-frequency oscillator, to modulate the cutoff frequency of the low-pass filter. So you'll hear the sound change over time as that LFO oscillates back and forth. Come on, come on. Yeah, there we go. So the code involved here, again, is relatively simple. We create our oscillator, create a filter. We tell it to use a low-pass filter. When you create the LFO, you give it a frequency that you want the LFO to oscillate at. And so here I gave it 2 hertz. And then the minimum and maximum values of that it will output. So I'm telling it to output frequency between 200 and 600. Connect it all together, and this is what we get. So it modulated back and forth on a 2 hertz cycle with the cutoff frequency. All right. Oh, so we have another demo right away. Kind of scattered these through here, so that's great. That's great. The next one is an oscillator with a saw wave. Again, I like the saw wave. If you can't tell, it's more interesting than a plain old sine wave. This time we're going to use an LFO to modulate the frequency of the oscillator, because again, the frequency is a modifiable thing, and you can modify it over time. So the cool thing here is that if you take a look at the line where I'm defining the LFO, I'm giving it an LFO frequency of 1, so that's 1 hertz, and instead of giving it actual like values in hertz, I actually just use tone to change a note value to a frequency for me. So it's got built-in conversion functions for all this. And I wanted to modulate the frequency between an E2, a second octave E, all the way up to an E5, a fifth octave E. So we don't have to memorize frequency values, because who wants to do that? We can just let tone do the work for us. So here again, very simply, we're creating the oscillator, creating an LFO. We connect the LFO directly to the frequency, so the frequency property of the oscillator itself, and it just changes it on that cycle. All right, so now we get into instruments. So instruments are pre-built synthesizers that pull together, again, multiple building blocks into a single object. So we have things like a simple synth that Tone creates for us, and all it is an oscillator connected to an amplitude envelope. So much like I showed you with demo 2, where I manually connected an oscillator to an amplitude envelope, it's already got that pre-built for us, so we don't even have to mess around with wiring that up ourselves. And that comes with all the goodness of being able to trigger that synth with a single function. It goes further. It has built in a mono synth, which gives you an oscillator with an envelope connected to a filter with its own filter envelope. So it's a pre-filtered synthesizer, and you can change all the filtering values through setup or on the fly. So each instrument has its own manipulatable values, and they differ based on what kind of instrument you choose. And they all have trigger functions to actually play the note that you want to play. So you don't have to start the oscillator and stop the oscillator. You just go ahead and trigger the note. So just for fun, I decided to kind of conjure up an approximation of a drum kick. Now, synthesizing drum kicks is actually pretty hard, and there's a lot of math involved that I certainly don't understand. But you can do a pretty good approximation of a drum kick using an oscillator with a sine wave, and then ramping the frequency of that oscillator down pretty quickly, and at the same time having an amplitude envelope that lowers the volume along with the ramping down of the frequency. So this contains a little more code, and I guess one thing to point out with this is the second line there has a thing called a scaled envelope, and all the way at the end, there's a property called attack curve, and it's an exponential attack curve, and that allows us to tell the envelope to just automatically use an exponential curve when it modifies the value. So which is really nice, and all that stuff is already available down in the Web Audio API. It's just this abstracts all the fiddly bits out and all the math, because if you take a look at the source code behind Tone, there's a fair amount of math that goes into modifying values. So go ahead and try to trigger the drums here. Actually, it actually sounds worse through here. It sounds better through the speakers of this. All right. You know, it's the poor man's drum kick, but drum synthesis is hard, and there's very long articles written about it. This is just to kind of see, you know, what we can make it do, and the relative complexities and kind of hooking things up. So the way we actually triggered this is actually calling the trigger function on both envelopes at the same time. So the interesting thing here is that the first value of that trigger attack release function is a note duration, and the second value is time to start the trigger. So I just put plus 0.01 on both of them, and that will schedule both envelopes to be triggered 0.01 seconds into the future. So they should trigger at the same time. All right, try. See, there might be another. I might have another demo here right away. Yeah, we'll see. Oh yes, okay. So we can kind of put some of this stuff together, and so that's great that we can play one note. Maybe we want to try our hand at making some kind of music. We can give it a shot. So I have some code where I've created used some of the synth instruments, and created kind of a pattern notation that can be read. And then I use the transport objects triggering functionality to play the notes repeatedly. So I can show, let's see, is that even visible? I don't know how visible that is, but.
Can you put it in a white background? It helps with the video viewing.
Oh, geez. I don't even know how to do that with Adam. I like the black background, so I leave it. How easy is it to do? All right. All right. Yeah, go ahead. Let's leave it on black. Oh, look at that. Oh, let there be light. Oh, it's just too bright. Really? No. Is it the other one?
Yep, there you go.
Oh, there we go. All right. Woo!
Thank you.
All right. Now we can see this better, except it's blinding me right now. There's a reason we like it with the black background. So this still is relatively simple. I just created a few arrays here in which I have some random notes, and then I have a beat. Cool, a beat. So I'm using a couple of monosynths that are built into Tone. Tone comes with its own drum synth that does a better job of approximating a drum kick than I can do manually. And basically, I just connect all three of those synths directly to the master. And the real key here is this set interval function. So you define a function that you want to have called back every time the interval hits. So all it does is it goes through these patterns, checks to see if there is a note in there. If there is, it triggers the note. So for notes 1, which is connected to synth 1, I use 16th notes. For notes 2, they're all quarter notes. And Down here, the actual drum kick is an eighth note. So that's relatively simple. All the way down here on line 293, that's where you specify the callback interval. So I'm telling it every eighth note, call my function. And you can use time in there. You can use any of those different time notations that we went through at the beginning. You'll see that this is typical for all of the code examples, and these are all up on GitHub. You have to start the transport itself so that it actually is running and doing something, and that starts the oscillator that's backing it. And I just set a default value for BPM and the master volume. I scaled way down.
What's the analyzer?
So analyzer. Mozilla has a nice little page that talks about all the different functionality of the built-in web audio audio analyzing functions, and they actually link to their own GitHub repository where they have a bunch of code that generates our little waveform up at the top. So it's reading the frequency values over time and generating the lines for us.
That's a browser function.
That's built into web audio. There's code to draw things based on the values that it pulls out, but it's actually reading the frequency values that's going through the interface.
That's only visual.
What's that?
That's only visual then?
Well, you can do all kinds of stuff with the analyzer functions, and I know Bryce has a project that does a lot of stuff with the analyzer.
We do student testing is the software that we're working on, and right now the stuff that we're working on allows the students to basically record their answer using web audio. So when you have a microphone, headset, that kind of thing, it's testing how well they can speak English. It's for English language learners. So they speak their test, and we field tested this last spring, and about 20% of the respondents that came in were either too quiet to hear or were muted. They were hardware muted and they didn't realize it. We have some checks that they're supposed to go through right before they start the test that verifies that they can hear their own voice. Some people just click through that and just say, yep, everything's fine, yes, yes, yes. But so what we've done now is we have analyzer nodes that basically will go through and say, was there at least this much audio, 1.5 seconds, that exceeded this average volume level? And if so, it lets them pass. If not, then it says, hey, maybe your microphone's muted. Why don't you try that again?
So there's a lot of different stuff that you can actually use it for, not just visualizing. And I have seen other demos out on the internet that use the analyzation capabilities to generate really nice visualizations based on the actual audio information coming through. So I just threw this in there. I didn't write it. I cribbed it directly from Mozilla. I do credit them though. So everything I just showed you there, this is what it sounds like. So rudimentary, you can get as complicated or complex as you wish. But just goes, there's a very wide range of what you can do with tone and web audio in general. From the very simple creating an oscillator to the very complex in generating events that play sounds at a specific time, or having a crazy node setup of different audio nodes and different oscillators to make different sounds. So I'm not actually going to demo this, but so part of my interest is live coding, like I said at the beginning. But tone.js, all in and of itself, isn't really helpful for actually physically coding stuff on the fly. It's great to write code that modifies things on the fly, that changes audio based on controls on a web page. But that's all pre-programmed in. and using either like a slider input or other inputs on a page, or you've pre-programmed changes to occur over time. Part of my interest is actually changing the code and having that change represented immediately. And everybody can kind of think of, would you really want to do your programming in the Chrome console or any other browser console? And probably not. It's kind of limiting, right? It's not a real REPL. There is, however, a project called Gibber, Gibber, that does provide you a REPL environment written in JavaScript, and it uses web audio behind the scenes, and it does give you a pretty nice live coding facility through JavaScript. Okay. This is a fun one. So, like I said earlier, I also want to get kids more interested in programming. So, there's some software called Snap. And Snap is actually a clone of Scratch. It's written in JavaScript. So Scratch right now is a Flash-based tool. They also have, I believe, Scratch Junior that runs on tablets. But Scratch itself is Flash. Okay. But a few people decided that they wanted a more extensible version of Scratch. Scratch really isn't hugely extensible in its base format. So Snap allows you to create your own custom blocks. You can also modify the source code. So it's written in JavaScript, and so I wrote some custom code to try to add in tone capabilities to the Snap environment. Oh, here it is. Okay. So if anyone's used Scratch, this is what Scratch looks like. And you basically have these blocks on the side, and you drag and drop them and kind of put them together. And you can create animations over on the right-hand side. You can have inputs and outputs and all kinds of stuff. It's a tool to create interactive things. And it makes it easier for kids to learn the basics of programming without having to deal with the syntax of actually writing code. So I modified this to add in the section of tone blocks. Well, there's only one block right now. We do what we can here. So I have a block that says oscillate note, given a note, for time, and give it a time. By default, it's a C3, a third octave C, that's going to run for a quarter note time. So I can come over here and I can connect up this cool when the green flag is clicked. You can click it here, or you can click it up there. Cool. So I can change the note. I can give it a time. So maybe I want to run it for 2 seconds. So not really all that hard to give rudimentary functionality to kids. This goes far and above what the built-in sound capabilities of Scratch or Snap can do. They let you have notes or sounds that are in a file, but that's it. I would absolutely love to have a lot of extra time to spend to really put some time into this to make it easier for kids to try to understand sound and audio synthesis, but in this environment. I think it would be a lot of fun to actually get fully working. All right, what else do I have? Oh, you're going to start there. Okay. We'll keep going. Possibilities are endless. All right. So here are some takeaways from this. One thing to note, that in the raw web audio API, once you stop an oscillator node, you can't restart it. You have to get rid of it and recreate it. So you'll usually you would manage that by connecting the oscillator to a gain node and manipulating the volume. So you want the note to sound, you turn the volume up. you want it to stop, you turn the volume down. So Tone handles this transparently through envelopes and trigger functions. You don't have to worry about it. Plus, Tone oscillators themselves can be started and stopped, and you can restart them and then stop them, restart them and stop them if you want to. But usually you'll just use envelopes. So to do more complex things, you're going to have to manipulate audio param nodes, and an audio param node is a signal in Tone, and you'll need to use some math. So to do more complex things in Tone, you'll probably still have to hand code some of that math. But if all you're interested in is hooking up what Tone gives you, and there's actually a lot to it, then it can be a lot easier without having to resort to any of that. So Tone abstracts it into different components and that handle the math behind the scenes. So one thing that I've read is that it's easy to use a lot of script processor nodes when using web audio. They're really, really inefficient, and if you get too many, you're going to get time slippage. Things won't be on time. So that's already deprecated. Things move fast in web audio, which is probably why things work and then don't work from every upgrade of Chrome. It's some kind of, I think it's a web worker node or something now, if I remember correctly. But Tone still uses a single script processor node to implement the callbacks inside tone.transport for the oscillator timing. It doesn't use any other script processor nodes. It bases everything on the tone.transport. So one thing I really like about Tone is the different ways to symbolize time. That's a fantastic thing. And the fact that Tone scales those times when you modify the tempo so that the relative timing is still correct is great. So you don't have to recalculate anything to make sure things still trigger when they're supposed to. Note names are automatically converted into frequencies when you tell the oscillator what note you want to give it. It's always easier to use that. You know, A4 is usually easy to remember, but who remembers all the rest of them? All the pre-built instruments and effects really reduce the boilerplate of the web audio management code that you have to have. And it exposes a single dispose function on every single component. So when you're done using it, you just call the dispose function and it cleans everything up. And there can be a lot of stuff behind the scenes of each of the components depending on the kind of component it is. And it's always fun to get the audio context. Usually you have to have a block of code about yay long to try to figure out, actually get the audio context. That's all hidden by Tone. It gets it automatically. But Tone doesn't support everything that web audio gives developers access to. That wasn't the goal. The goal was to provide an easier building block way to synthesize audio without having to deal with some of the underlying management. So, have fun. Here's a bunch of links, presentation, and the demo HTML is on GitHub. Enjoy. That's all I got for you. Questions?
Is web audio supported by the major newer browsers?
Yeah.
Including tablets and everything.
Yep. Yep. Absolutely. In varying degrees, I'm sure.
Yeah, I mean, it's absolutely exactly that. I mean, every browser kind of, I mean, the parts that they support basically the same way. We haven't run into things where like the same thing behaves differently, but there's some notable exceptions where, like for example, if you want to use the microphone in the browser, typically what that'll do is it'll prompt you when your code asks to access the microphone. The browser will ask the user, do you want to let this application use the microphone, right? So they have to say okay, and then you can use the microphone. On the tablet devices, sometimes they just don't let you do it. So like on iOS, you can't use the microphone from HTML. Period. End of story. Not an omission, not a feature coming soon, not a we have technical challenges doing this. It's a never gonna happen, don't count on it, you know? And so we're actually, one of the things that Scott was talking about is creating these nodes in web audio a lot. Web audio is kind of designed with the sense that the nodes that you're creating are kind of idempotent. So you create it, it's attached, it does its work, and then it's gone. Or it keeps doing its work, but it's the same work. It's not really designed to say, hey, I'm gonna create some things and I'm gonna change how they behave over time. Or, you know, I don't like what it's doing anymore, I'm gonna change it. And so one of the tricks that we're doing on the iPad to support this student being able to record their voice, is the application, the native application can access the microphone and it says, you know, do you wanna use the microphone, blah, blah, blah. So then, yeah, so it basically queries the audio data from the native side to the JavaScript side by sending in about 800 frames of audio at a time. And we create a processor node every time and say, hey, there's more audio, here you go. Here's more audio, here you go. And we do that at 800 frames a time, 48 kilohertz or something like that. And it's actually performing. I mean, you wouldn't necessarily think that it would be, but it actually is. This stuff is super low level, the web audio stuff is. It literally, comparing it with synthesizer and plugging things in is just not far off the mark. I mean, just as well as you can like just shock yourself if you plug things in wrong on your synthesizer, it can do the equivalent of that with web audio. The ToneJS is a really nice abstraction layer over it.
Any questions, thoughts? Yeah.
You said you can, and I don't know if it was tone or the underlying web audio stuff that lets you play back like an MP3 file. Are you able to get an encoded stream out of it? Like if you recorded somebody's voice? No.
No.
You would
That's
have to
another
handle
one of the
something
limitations
yourself.
that we have. We actually have to ferry the PCM data off to a local system that is, so the architecture has this local computer. It basically takes the PCM data, encrypts it as OGG, and then sends it back to our servers because otherwise we would just be overwhelmed by the data. So,
It's just data. There's no other capabilities but playback.
yeah.
Okay.
And I would actually, so there's a bunch of things that web audio does really well. One of the things that is not really great is just playing audio files. If you're just gonna play audio files, use the audio tags. There's a bunch of JavaScript control over that now that didn't used to be there. But the web audio stuff is great if you're generating audio. If you're playing audio files, it's horribly memory inefficient. You get into all, because what you're basically doing is you're getting an MP3 file and you're saying, hey, I have this byte buffer, decode it. Oh, okay, now I have this PCM buffer, play it. Whereas if you just use an audio tag, you can say, here's an MP3 file, play it. And it just handles all of that stuff kind of on the non-JavaScript heap side of memory, which is kind of what you want because it's being managed better than you can.
But raw is all you can get.
It's for any data that's coming out of it, whether it's generated or sourced from the microphone, all you can do is raw. It's PCM unencrypted wave data, basically. Yeah, it's yeah. I mean, you do have control, which is nice, thankfully.
Sample rate.
For sample rate and channels, like you can say, I only need 24 kilohertz mono or something like that. So that's nice. Otherwise, the data would be even more huge than what we do. But it's still pretty big. Pretty unwieldy, so. And the weird thing is, there's no RFCs. There's no working groups. There's nobody anywhere that I've seen that's working on anything to give you anything better out of the browser, which is really bizarre because you think that, you know, with things like Siri and, you know, all the voice interaction type of things that they're kind of going for, and Apple just made a big play with their TV stuff, and I mean, everything's getting to be an Amazon Echo. You know, you'd think that getting voice input and then shipping it off to a server somewhere would be like the thing that you want to do, and you know, even Chrome's, what is it called? They have a speech to text thingy that only works in Chrome. That's a private API that nobody else can use.
I think it ships it off to like
It ships it off to the server, and it's not it's there either. So they're just able to use such a small sampling rate and constrain it that way that they can make their bandwidth work, but it's not designed. Like, you're not gonna see something, for example, that's like, oh, hey, plug in your guitar to your browser and, jam and upload to the cloud. It's not happening. Nobody's really doing that.
Not-
So,
Not quite yet, but people are doing, turning the browsers into amplifiers and distortion boxes.
nice.
I was at ToneJS last year, and they did a web audio API hack day, and then at the end of the conference, they kind of showed off what people, the best of the best. And one of the guys actually, and I think the video's out there somewhere, he actually brought his guitar and plugged it in, but he, there was a lot of physical wiring that needed to actually take place in order for it to work. Because of looping back in on things and
Any other questions? Yeah.
Do you know, I know this is kind of a tangent, but Create.js, it's kind of like the release, I guess, new Flash replacer or whatever, it's a JavaScript framework. They have Sound.js, which is another component of that, if they're using web audio or video or whatever.
I think that's not it.
Yeah, I know nothing about it.
This is not okay.
I believe so.
And you can, I wouldn't recommend going down this path, but you can actually just feed the audio tag data. Like, it doesn't really care where the data comes from. You can give it a source file and say, go fetch this audio file,
Yeah.
play it. You can also just give it a blob of data, and if you know how to format it correctly, it'll happily play that data like it would anything else, but if you're going down that path, you're much better off using the web audio stuff. So we were able to do things like, there's algorithms out there for you to do pitch correction, which never used to be supported on the audio. So, like, one of the things that students like to do is when they're listening to audio, they don't want to listen to it, Greg knows this, they don't want to listen to it at 1x speed, they want to listen to it at 1.5x or 2x speed because they have to listen to a lot of audio. So, well, what happens when you just make an audio file play faster? It sounds like the chipmunks. So you have to pitch correct it. Audio tag didn't have that support before, so we had to use web audio, and it's pretty simple to use to do it in web audio. There's an algorithm you can just copy and paste from Stack Overflow or Mozilla or somewhere, but the audio tag now has the ability to do that automatically. You can just say, hey, the speed changes, pitch correct it for me, and it'll do that for you.
All right. Well, thank you very much.
thanks again.